Welcome to another unit on how to work with the formulary in Statistics 2. In this context, I want to talk about the tables we find in the end of the formulary and how to use them. Well, the first table we see is this table on the percentiles or quantiles of the standard normal distribution. Here, the first row actually lists the values for 1 minus alpha. So if alpha is 5%, you get this part here. If alpha is 2.5%, you would get this one. In this regard, I just wrote here that 1 minus alpha. Of course, if you have 1 minus alpha half and an alpha of 5%, this also gives you alpha z 0.975. So you also have to look up this value here. So this just a specific type of writing, meaning you calculate the 1 minus whatever is given there, and then you look up this value here in the first row and take the value from the second row. And that's basically all there is on using this first table. And that's what is used in the context of a Gauss test or the first type of confidence intervals when we have a given standard deviation or variance. The second table on the values of the cumulative distribution function, that's when we want to actually calculate probabilities based on a normally distributed variable. Here we calculate the standardized values, positive standardized values, then we look them up in this table. This table requires that we have a value we look up, which is rounded to the second decimal. Then we start with the row, which gives us the value before the decimal point and the first decimal. Once you found the corresponding row, then you take a look in the specific columns which list the second decimal. So if we're looking up the value 1.08, we go into the row for 1.0, and then we go into the column for 008, because the second decimal would be 8 if I have 1.08. So here I would use this value. If I have the value 0.66, I would go into the row of 0.6 and a column of 0.06, this one here. So that's on how to use this table for the standard normal distribution. The next one, that's actually the table on the t-distribution, which we need for the t-test, comparing means, which we also need for confidence intervals, where we don't know our variance or standard deviation, and which we need for the t-test, the coefficient test in the regression context. Here I have two values. The first value is the degrees of freedom. Those are actually listed here as rows. And we need the certainty, which is just referred to as alpha here. So in this case, you directly calculate like 1 minus alpha half, whatever. And then you look up the corresponding value here as a column. So if we have, for example, 5% error, 0.95, you would look this up in this case. While this works decently fine, if you only have a small number of observations, because here they are all listed separately, if you have a larger number and the specific values are not listed in this table, what you can do is you can round up or down to the next value in the table and use the corresponding value as an approximation. Usually there's not this big a discrepancy if, for example, you have 600 and you round to 500 and take the value for 500. Which also goes for the next two distributions we might talk about, which are the chi-squared and the F distribution. So if the value is not in the table, round to the next possible degree of freedom. So I said the next distribution, the chi-squared distribution, this one works similarly to the T distribution. So here, the columns, again, give us the certainty, the alpha, whereas the rows give us the degrees of freedom. So first you check the degrees of freedom, select the corresponding row, and if you are in the corresponding row, you take a look, what's the value here for alpha. For example, if you have an error of 5%, you get to 0.95, so you would go to this value. So T and chi-squared distribution, the tables work more or less the same. However, the last two pages have the F distribution. Here we have a problem, as in we have 2 degrees of freedom. That's also the reason why we have 2 tables. We have one table, which is actually for 5% error, for 0.95. And we have the second table, which is for 1% error, which is for 0.99. In either case, you first select the corresponding table based on your error probability, and then you take a look at the 2 degrees of freedom. Insofar, the first value, which in most cases should be the smaller of the two, actually gives you the column. And that's limited only to 10, because, for example, we use this in linear regression. This is the number of independent variables. And well, you wouldn't get a regression with more than 10 independent variables. So first, select the corresponding column, then go with the second value. That's actually here the row. That's observations minus number of independent variables minus 1. This can, due to the number of observations, become relatively large. So this is why this table continues downwards, and you have numbers like 500, 1000 down there as well. Again, as with chi and T distribution, if the value is not on the table, round to the nearest possible row. However, for smaller numbers, you can actually find the values here. So first, in this case, select the corresponding table. Then within the table, check first degree of freedom regarding the column, then second degree of freedom regarding the row, giving you the specific value to use. Well, that's then everything there is on using these tables in the context of the formulary. So I say goodbye and see you next time.